Have you ever looked up at the night sky and wondered, are we alone? It's a huge question, one that gets right to the heart of what it means to be a thinking, feeling human being on this little planet of ours. For thousands of years, we could only guess. The stars were just twinkling lights, beautiful, mysterious. But now, things are different. We have science. We have telescopes that can see farther than anyone ever dreamed. And with these amazing tools, we've started to find other worlds orbiting other stars. These are called exoplanets, and finding them has changed everything we thought we knew about our place in the cosmos. Consider this. There are more stars in the universe than there are grains of sand on all the beaches on Earth. Now imagine if even a tiny fraction of those stars have planets. It's mind-boggling. Among the thousands of exoplanets we've discovered, a few stand out as particularly exciting. One of the most famous is a world called Kepler-22b, and what we found has opened up a whole new frontier of exploration, all without ever leaving home. Why is this one so special? Well, it was one of the first planets found orbiting squarely in the habitable zone of its star. Let's go explore. So where is this amazing world? Kepler-22b is far, far away. It's about 638 light-years from Earth, in the direction of the constellation Cygnus, the Swan. To put that into perspective, a light-year is the distance light travels in 1 year, which is about 9.5 trillion kilometers, or 5.9 trillion miles. If you were to travel in our fastest spacecraft, it would take you millions of years to get there. So, we won't be packing our bags for a weekend trip anytime soon. The star it orbits, Kepler-22, is a G-type star, very similar to our own Sun. It's just a little bit smaller and cooler, which means its habitable zone is a bit closer in than ours. How did we find a planet so incredibly distant? We have the brilliant Kepler Space Telescope to thank for that. Kepler used a clever method called the transit method. It stared at a single patch of the sky, monitoring the brightness of more than 150,000 stars simultaneously. The idea is that if a planet passes in front of its star from our point of view, it will block a tiny amount of the star's light, causing a very slight temporary dimming. It's like a tiny gnat flying in front of a distant car headlight. Kepler detected these periodic dips in starlight, and by studying how often they happened and how much the light dimmed, astronomers could figure out a planet's size and its orbit. The discovery of Kepler-22b was a big deal. Scientists first noticed signs of it just a few days after the Kepler mission began in 2009. But science requires a lot of checking and rechecking. To be sure, astronomers needed to see at least 3 transits. They finally got that crucial third transit in late 2010, and after careful analysis, the discovery was announced to the world in 2011. It was a moment of pure scientific joy. So, what do we actually know about Kepler-22b? Let's break it down. We know it's about 2.4 times the diameter of Earth. This makes it what astronomers call a super-Earth. It's bigger than rocky planets like Earth. It's bigger than rocky planets like Mars, likely smaller than ice giants like Neptune, likely smaller than ice giants like Uranus. We don't have a planet like this in our solar system. No direct comparison. This size means its gravity would be stronger than Earth's. If you could stand on its surface, you might feel more than twice as heavy. That would certainly make jumping a lot harder. We also have a good idea of its orbit. Kepler-22b takes about 290 Earth days to make one full trip around its star. That's remarkably similar to Earth's 365-day year. Its star is slightly cooler than our Sun. That places it right in the habitable zone we talked about. If Kepler-22b has an atmosphere, and that's a big if, it could have an average surface temperature of around 22 degrees Celsius or 72 degrees Fahrenheit. That sounds pretty comfortable, doesn't it? It's like a perfect spring day, which is very exciting when you're talking about a planet hundreds of light years away. Now for the big question, what is it made of? This is where things get a bit more speculative. Because of its size, scientists have a few different ideas. It could be a rocky world with a very thick atmosphere. Or it could be something completely different, like a water world, a planet entirely covered by a deep global ocean. Imagine a world with no continents, just one vast planet-wide sea. Another possibility is that it's a mini Neptune, a gaseous planet with a thick hydrogen and helium envelope and no solid surface to stand on. We can't know for sure without more data, which is a major goal for future telescopes. The possibility of liquid water is what makes Kepler-22b so tantalizing. Water is the key ingredient for life as we know it. Let's use our imaginations for a minute. What would it be like to visit Kepler-22b? Let's assume the best-case scenario. Stable, ocean-covered, a super-Earth with a breathable atmosphere. The first thing you might notice is the sky. The light from its star would be a bit warmer in color, maybe more golden or orange. Because the planet is larger, its horizon would appear flatter and more distant. Standing on a boat in the middle of that global ocean, you'd be surrounded by an endless expanse of water under a sky that feels both familiar and alien. The air might feel thicker, heavier, due to the planet's stronger gravity and potentially denser atmosphere. Now, think about the life that could exist there. If life began in these oceans, it would have evolved under conditions very different from Earth's. The higher gravity might favor creatures that are built low to the ground or are incredibly strong. Perhaps life would be mostly buoyant, floating freely in the planet-wide ocean. You might find vast floating forests of kelp-like organisms. Maybe there would be giant, gentle filter feeders like our whales or swift, bioluminescent predators that light up the deep, dark abyss. The colors could be completely different, adapted to the specific wavelengths of light filtering down from the star. What would a day be like? With a 290-day year, the seasons, if they exist, would be slightly shorter than ours. We don't know how fast Kepler-22b spins on its axis. The most habitable area might be the Terminator Zone, the twilight ring between hot and cold. Can you imagine living in a world of eternal sunset? So why does any of this matter? We have plenty of problems here on Earth to solve. Why spend time and resources studying a planet we can never visit? Because it changes our perspective. Learning about Kepler-22b helps us understand Earth in a profound new way. By studying other planets, we learn what makes a planet habitable, a little bigger, a little closer to its star, a different kind of atmosphere. It's like running experiments on planets, helping us protect our own. The search for exoplanets is a deeply human endeavor. It connects us to generations of thinkers, explorers, dreamers. It unites people across cultures and borders. Discoveries belong to all humanity. It satisfies our innate curiosity about our place in the universe. This quest pushes technology forward. Benefits appear in medicine, computing, engineering. It gives us cosmic context. Our galaxy might contain billions of habitable zone planets, humbling and exhilarating. Earth becomes a more precious, fragile oasis. We must be good stewards of our home. Other worlds make ours infinitely more special, our home base. Looking for worlds like Kepler-22b is about looking for ourselves. Understanding life, now and in the future. Are we a rare fluke? Or is the universe teeming with life? We don't know yet, but we have the tools and the will. Every data point is a clue in the greatest detective story. That's a journey worth taking. It inspires, it challenges, it makes us look up and wonder. That's what science is all about.